Hi everyone, so welcome to the second video of our outline statistics. Let's see the agenda of today's lecture. The learning objectives of this lecture are to: first of all, we will learn about what is variance and variation. Then we will see what is range. Next, we have quartile and percentiles. In the last, we will study about what is standard deviation. Let's move forward. So what is actually variance? Variance is a distributional measure that aids in describing the form and distribution of the data. It is computed by calculating the difference between each data point and the average, also referred to as the mean, squaring the difference, adding all the data points together, and then dividing by the total number of data points in our data set. Our language has following function that can be used to determine or find out variance. So let's see its syntax. We just have to use the variance keyword, and then we have to pass the variable or data frame. So let's use it. Well, first of all, I will set my working directory, data size R. All right. Now let's say I load the packages such as dplyr. All right. And here I create a variable with the name of variance. And this variable contains a vector of values such as 2, 4, 6, 8, and 10. Now, in order to calculate the variance of this variable, I will say print, and then I will use the keyword of var, as you can see. Then I will pass the variable, which is variance. Let's run it. So you can see here that the variance is 10. Let's take another example. For this example, I will create a variable of msleep, and I will say read.csv, and I will say read the msleep.csv file. And here I will say head msleep. Let's run it. Now, for instance, I want to calculate the variance for the variable of sleep total. All right, let's do it. Variance of sleep total. And inside this variable, I will store the variance by saying var msleep, and inside the msleep data frame take the column of sleep total, and here I will say print var sleep total. So the variance for this column is 19. This is actually how you can calculate the variance. Now let's move back to slides. Variation. Variation is a measurement of how dispersed the data is from its center point. The statistical distance between the values of the observation or data points is what makes a measure of variation. There are various ways to measure variation. The most frequently employed is to calculate or find out range, quartiles and percentiles, interquartile range, and then the standard deviation. We will see all of these things by making visualizations in the next outline of this course. So far, we will just use the functions. So what is actually range? The range is the most basic way to describe variance and how dispersed the data is. To determine the range of the values, the difference between the data's lowest and largest value is calculated. R has the following function to show the values from smallest to largest, which is range given. Note, the spread of data increases with range size and vice versa, which is quite obvious. So let's move to our studio to see how we can calculate the range. First of all, I will say head and sleep. Now, for instance, I want to calculate the range of sleep total. So first of all, I will say min sleep total, and inside this variable, I will store the minimum value of sleep total. And similarly, I will say max sleep total, and inside this variable, I will use the max function, and I will say take sleep data frame and the variable of sleep total. Now, I want to store my range in a variable, let's say range 1, and I will say max sleep total minus minimum sleep total. And here I will say print range 1. Now let's run this chunk of code. So you can see here that the range is 18. An alternative method for doing the same task is by using the range function. I say range 2, and inside this variable, I will use the range function, and I will say take the sleep data frame and calculate the range for the sleep total column. And here I say print range 2. Let's run it. Now let's move back to slides. Next, we have quartile and percentiles. So measures of variation, such as quartiles and percentiles, show how evenly distributed the data is. By using them, you can divide the data into 4 groups of equal number of values. The data's smallest value is Q0. The number Q1 represents the 25% of the data, and it separates the first quarter of the data from the second quarter. The number Q2 represents the 50% or half of the data, which divides the bottom from top half. Next, we have the number Q3, which represents the 75% data. It actually separates the third quarter of the data from the fourth quarter. In the last, the data's biggest value comes from Q4, which represents the whole data. The syntax is quite simple. Just use the quantile function. Let's move to our studio to see how we can find the quantiles. All right, so here I will say once again head and sleep to see the head of my data frame. And for instance, I want to see the quantile for sleep total variable. Here I will create a variable as quantile 1. And inside this variable, I will say quantile, and I will pass the data frame, and then the column name, which is sleep total. And here by saying print quantile 1, I will see the quantiles. So you can see here the 0%, 25%, 50%, 75%, and 100%. The first one represents Q0, the next one represents the Q1, and 50% represents Q2, 75% represents Q3, and 100% represents Q4. Now you can see here that most of the data is around 10.10. and the 25% of the data is around 7.85, and 75% of data is around 13.75. Now, let's do the same thing for another column. Let's say quartile 2, and I say quantile. By using this function, I pass the data frame and then the variable name sleep total, and by using the print, I will say quartile 2. Sorry, the column which I wanted to use is body weight. Let's see the quartiles. So the median most value, or Q2, has 1.6 value. So this is actually how you can use or see the quartiles of your data set or variable. Let's move forward. Next, we have percentiles. So percentiles are used in statistics to give you a number that describes the value that a given percent of the values are lower than. These are the values that divide the data into 100 equal pieces. The 25th percentile, or P25%, is the same as the first quartile. The 50% quartile is the same as the second quartile and the median. The 35th percentile is the same as the third quartile, which is Q3. The 95% quartile separates the lowest 95% of the values from the top 5%. The syntax is quite simple. Just use the quantile keyword as you did previously, then pass the data frame, then the variable or column, and then here by using the combine function you pass the percentile. Let's move to RStudio to see how it works. So I will say percentile 1, and inside this variable I will use the function of quantile. I say find out the percentile for mSleep data frames variable of sleep total, and here I will use the combine function, and I will say that count me the 0.50 percentile. Here I will use the print function, and inside this print function I will say print the percentile 1. Let's run it. All right, so you can see here that it's 10.1 or 10.10. That is the same as you have seen above for sleep total. So this is the median. Now you can do the same thing. Let's say percentile 2. And here I will use the quantile function. I will pass the data frame, then the variable, which is body weight. And this time, I want to see the 0.25 percentile. I use the print function, and here I give the variable percentile 2. Let's run it. So you can see here that the 25th percent or 0.25 percentile is 0.17, which is the same as above. Now let's move back to slides. The difference between the third quartile and the first quartile is known as interquartile range, also known as middle 50% or formally adjusted rate. It contains half of the observations and covers the middle of the distribution. Now here we have some points to consider about IQR or interquartile range. The value in the data that divides the bottom 25% of values from the top 75% is known as the first quartile. The data value separating the bottom 75% of values from the top 25% is known as the third quartile. So let's see the syntax. Just use the IQR keyword and pass the values from the data frame or from the variable. Let's implement in RStudio. I say I want to calculate IQR1, and here I use the function of IQR, all right? And inside this function, I say calculate the quartile for the column of, let's say, sleep total. Let's print IQR1, all right? So you can see here that it's 5.9. It's the difference between the third quartile and the first quartile. You know that 13.75 minus 7.85 is actually 5.9. So this is how this function works. Let's say IQR2, and here I use the function once again, IQR. I give the data frame, and I say calculate the IQR for body weight, print IQR2, and let's run it. 41.57. So this is the difference between the third and the first quartile. Next, we have standard deviation. The square root of variation is known as standard deviation. It is a gauge or measure of how much the data deviates from the mean. The syntax to find the standard deviation is SD and then pass the data frame or the values. Let's implement. Let's say standard deviation 1, and inside this variable, I say calculate the standard deviation for the data frame of mSleep, and I say take the column of sleep total, and here I pass a parameter na.rm equals to true to ignore the missing values, and here I say print sd1. Let's say. So the standard deviation for this column is 4.45. So just like this, you can calculate the standard deviation for other columns as well. Now let's move back to slides. All right, guys, so this is the end of today's lecture. You have learned about variance, variation, and the range and quantiles. So here I have designed a little homework for you. You have to find the variance and standard deviation. You also have to find out the quantiles. The link of the dataset is given. So now, good luck. See you next time.